To better understand how file format and file size affect the performance of querying and analyzing data, we're going to look into a simplified example of IoT data journey from transmission into data analytics. And today, this example is highly used in factories when they want to mitigate issues and save on expenses by attaching sensors that can help them later monitoring everything that happens in the factory, also make data-driven decision based on that by running some analytics and using tools such as machine learning to extract insights. And one of the prominent examples is valve monitoring and valve management, where we can collect events from all valves in the factory, and later on analyze their behavior and what happened with them. This is the good side of the things. The challenging side is often results in a huge amount of data. And since we want to be able to respond relatively fast or to have ad hoc queries that run fast, we want to make sure our data systems is designed for it. So for this demo, I already mimicked IoT event data that is ingested into our system with structured streaming. And we're going to test out two different storage formats and evaluate how they work. So in the factory, imagine that I have my measure and control, and my measure and control is constantly sending events, telemetry stream into my analytics platform, into my data warehouse, where later inside the data warehouse, the data is being extracted, processed, organized, enriched with other enterprise data or external database in order for us to extract insights and run analytics on top of it. For capturing the telemetry for data analytics, you can use tools such as Apache Kafka, which is scalable and highly available as well. So it can really helps you capture high throughput of data. The challenge is each event can have its own small JSON file that is being captured. And to run the performance evaluation on these JSON files, we're going to mirror the data that was captured from tools such as Apache Kafka into Parquet format and Delta format. So in order to do so, I created two different Spark read streams and two different write streams. One of the writes is going to read the data and write it into Parquet, and the second one is going to write it into DeltaLake format. In the file itself, I have my events, my schema. It has event ID, it has event name, it can be failed or open or any of such, and I have event time. Very simple example of the data. Using Hive that is already built into my Azure Databricks environment, I'm going to create a new table from the Parquet location. So here I'm creating if not exist, I'm creating a database, and I'm creating table 01, which is from a Parquet format, and I'm specifying the location. The second table is going to be a Delta table, specifying Delta format and location. And just to make sure there's no data duplication or no data got lost, I want to make sure they have the same amount of rows in each table. And I already know I generated 110 files, so there should be 110. And like you can see, there's 110 in the Parquet and in the Delta table. All right, now I want to see how long it takes me to query that table. So I'm going to run two identical queries that's going to select event name and event time. The only one thing that difference is I'm going to query that one. I'm going to run that query once from the Parquet and the second time from the Delta table. So running the Parquet one, and this one took me 1.56 seconds to finish. And now I'm going to run my Delta one, and that one took 0.90 seconds. All right, so the Delta one is already faster. I wonder if that's the case or there's something I can do about it. So for that, and you already know about it, we can use the Hive optimize command that helps me optimize the layout of DeltaLake Delta. Uh, so I'm going to use optimize and the Z order one. Let's run the Z order, save some space and on the data, and let's see what's happening. Num of file added, 1, num of file removed, 101. So what happened behind the scenes, my optimized query combined a couple of small files into one file. And the couple of small files is actually 101 files that were removed in one file that was added. They're already addressing the issue of small files. All right. Can we optimize Parquet table file? I mean, is optimized query can run on Parquet? And unfortunately, the answer is no. Analysis exception, delta table not found. It means it's only possible with the delta format. I can run this optimization with the delta format. Okay. So after I optimized, I deleted 101 files and I combined it into one file for my DeltaLake storage. Now I want to see if it even, if it made any change, what change in the performance wise. So Parquet table took 1.1 seconds and my DeltaLake table is taking 0.81 seconds. So yeah, definitely some change. Let's run it again and see what's happening. I know in the DeltaLake there should be, the caching mechanism should be kicked in at some point. So let's see what's happening with the optimization here. Yeah, absolutely. Definitely more prominent, 0.74 seconds. Yes, so running the Hive optimization by combining all these 101 files into one file and then adding the caching mechanism that Delta provide really helped with improving the run query. It's almost, yeah, it's half the time of what the Parquet query takes. So Delta table wins in our case.